Good morning, classmates, and especially to you, Sir Repanindangan. Sir, good morning. This is the continuation of my daily reports on trigonometry, in which I am going to report to you my fourth and fifth report, wherein we can find it in Leal, page 28, number 79 to 80, and in page 60, example 4 and 5. And we are going to discuss first on how we are going to find the indicated function value of the given situation. So first, let's go on to number 79. So in the situation in number 79, you are going to find the function value of secant 1000 degree. So to find it, we are going to transform first the expression using the reciprocal identity, so that we were going to have the result in which the result is 1 over cosine multiplied by 1800 degree. And the next is we're going to rewrite the angle as a sum or difference using the period of sine or cosine function, in which the result is 1 over cosine 0 degree plus 1800 degree. And the next step is we are going to simplify the expression using the period of trigonometric function. So the result of 1 over cosine multiplied by 0 degree plus 1800 degree is equal to 1 over cosine 0 degree. So therefore, if we are going to evaluate the expression, it will become into 1 over 1. So as we all know that any fraction with a denominator of 1 is equal to its numerator. So therefore, 1 divided by 1 is equal to 1. Okay, so now we have the indicated function value of secant 1000 degree, 1800 degree, in which the value is 1. Okay, and it is clearly defined that secant 1800 degree is defined. Now, let's go on to number 80. So in number 80, the situation is we're going to find indicated function value of tan 1800 degree. So what we are going to do first is we are going to rewrite the angle as a sum of difference using the period of sine or cosine function. So therefore, tan 0 degree plus 1800 degree. So the answer is tan 0 degree. What we do is we simplify the expression using the period of trigonometric function, and the next is we evaluate the expression, in which the answer is 0. So therefore, it is clearly stated that it is undefined, and the reason behind why it become undefined is that the tangent of an angle is defined as the sine of that angle divided by the cosines of that angle. So therefore, it is being called undefined. Okay, so let's move on to my fifth report in this meeting. In which we were going to find it in Leal, page 60, example 4 and 5. And we're going to tackle here in example 4 about how we're going to use function values of special angles, and example 5 using coterminal angles to find function values. Okay, so let's move on. But before we go on to our discussion, or before we go on how we are going to use function values of special angles, let's find first what is the definition of special angles. So as you can see, that the definition of special angles is the unit circle refer to an angles that have corresponding coordinates which can be solved with a Pythagorean theorem. Each of these angles are measured from the positive x-axis as the initial side, and the terminal side is the segment connecting the origin to the terminal point on the unit circle. So as you can see, that there is an illustration below that clearly stated about what is the unit circle has, or what is the special angles look like. Okay, so let's move on how we're going to use function values of special angles. Okay, So here is the situation. We are going to evaluate the cosine 120 degree plus 2 multiplied by sine squared 60 degree minus tan squared multiplied by 30 degree. So here is the solution. First, we're going to use the procedure explained earlier to determine cosine 120 degree is equal to negative 1/2. Okay, then use the values. So we're going to use the values of cosine 120 degree is equal to negative 1/2, and the sine 60 is equal to positive 3 square root of positive 3 over 2, and the tan 30 degrees is equal to square root of 3 over 3. Now, what we are going to do to our situation is we are going to substitute the values first. So the value of cosine 120 degree is negative 1/2. So therefore, negative 1/2 plus 2. The substituting value of 60 degree is positive 3, square root of positive 3 over 2. And the tan 30, the substituting value is square root of positive 3 over 3. So therefore, it equal to negative 1/2 plus 2 square root of 3 over 2 squared minus square root of 3 over 3 squared. Now, what we are going to do is we are going to apply the exponent. Okay, so the result is negative 1/2 plus 2 multiplied by 3/4 minus 3 over 9. So the question is 3/4, where it come from? So as I said while ago, that we are going to apply the exponent. So the 3/4 came from the situation in square root of 3 over 2 squared. So 3 times 3 is equal to square root of 9. So square root of 9. So what is the square root of 9? Is 3. So therefore we have 3. So 2 times 2, 4. So we have 3/4 minus 3, 9. So the question is, where we came from this, where we get this 3 over 9. So as I said, we're going to apply the exponent. So positive square root of positive 3 times square root of positive 3 is equal to 9. And what is the square root of 9? Is 3. So therefore 3. And 3 times 3 is 9. So therefore we have 3 over 9. Now we are going to simplify. So the answer is 2 over 3. And that is the answer of the situation that we are going that we use function values to evaluate the answer. Okay, so let's tackle about the example 5 in my 5th report about using coterminal angles to find function values. So but before that, we are going to talk about let's have the little background about coterminal angles. So when we say coterminal angles, it is all about the angles in standard position, angles with the initial side on the positive x-axis that have a common terminal side. So that is the main form of coterminal angles. So now let's move on. Okay, we are going to evaluate two situations. So the question is, evaluate each functions by first expressing it in terms of a function of an angle between 0 degree and 360 degree. So our first situation is cosine 780 degree, and the next situation is cotangent negative 405 degree. Now, in first situation, we are going to subtract. So it is clearly stated here in my report that we are going to subtract 360 degree as many times as necessary to obtain an angle between 0 degree and 360 degree. So which give the following. So cosine 780 degree. So this is the situation. Is equal to cosine 780 degree minus 2 times 360 degrees. So the question is, where we come from, or what is why we have this 2 times 360 degree. So as I said while ago, that we are going 2 times as necessary to obtain the angle between 0 degree and 360 degree. So 2 times 360 degree is equal to 720 degree. So as it's stated here that subtract 720 degree, which is 2 times 360 degree. So 780 degree minus 720 degree is equal to 60 cosine 60 degree. So multiply first and then subtract. Then we're going to evaluate. So as we tackle the example 4, that the value or the substituting value of cosine 60 degree is positive 1/2. Now let's move on to the next situation. We are going to find the solution for cotangent negative 405 degree. Okay, so what we are going to do first is we are going to add 360 degree twice to obtain negative 405 degree plus 2 times 360 degree equals 315 degree. So why we need to twice 360 degree? Because what we are going to find is, or what we are going to aim to find the answer is the positive of the negative 405 degree to find the reference angle, okay, which is located in quadrant 4 and has reference angle 45 degrees. So therefore, the reference angle of negative 405 is 45. So the cotangent will be negative. So therefore, cotangent negative 405 degree is equal to cotangent 315 degree. So it is equal to negative cotangent 45 degree, in which the reference angle 45 degree is equal to negative 1. So that's all. Thank you.